Good day everyone. Today we'll be sketching cubic graphs, still on the topic differential calculus. And then the first things first, remember that cubic functions are functions of the form ax to the 3 plus bx squared plus cx plus d. Then we come to the properties of a. If your a is greater than 0, it means that the last portion of your graph has to increase. And then if your a is less than 0 or is negative, it means that the last portion of your graph has to decrease. And then we also have to find something called stationary points, or as some may say, turning points. Turning points are these points of your graph. How do you find them? You take the first derivative of the graph, you equate it to 0, you find the x value of that point, and then you substitute that x value into the original f of x, not into the first derivative you just derived. And then a cubic function will look something like this, and then you'll have what we call a local maximum and what we also call a local minimum. The reason why they're called local max and not absolute max is because it's the maximum here, but it's not the total maximum of the graph, because any point above it here will be the maximum point of the graph. The same thing applies to this one. Any point below here will be the absolute minimum, the absolute minimum of the graph. So these ones are not absolute, they're just local. And then you also have something we call a point of inflection, which is a point where the concavity of the graph changes. How do you find that point of inflection? You take the second derivative of your given function, you equate it to 0, and then the x value you find there, also you substitute it into the original f of x, not into the second derivative. What does this tell us? It means that if the second derivative of yours is positive, it means that it's greater than 0. It means that at that particular point, your curve or your graph is concave up, so it's increasing. And then if it's less than 0, your graph at that point is decreasing. So apart from that on, they're also here sketching. How do you sketch it? You find the x and your y-intercept. How do you do that? You can look into the previous videos in this series. I showed you how to find the x and the y. And then you find the turning points I've just explained here, and then you sketch your graph. That's about it. So now let's do some examples and questions. So we're given this question. It's f of x is equals to x to the 3 plus x squared minus 5x plus 3. So the first thing you have to find your intercept. Let me change the color. The first thing you have to find your intercept. So how do we find that? Let's look for our y-intercept first. Remember, for y, you let x be equals to 0. And then if you let x equals to 0, it means that your y-intercept will be into 0 plus 0 squared minus 5 into 0 plus 3. So it means that your y-intercept will be 3. So we got that out of the way. Now we look for our x-intercept. So for x, obviously you let y be equals to 0, and then it means that you'll have 0 is equals to x to the 3 plus x squared minus 5x plus 3. And then from here on, you factorize by inspection. That's how I will do it. I'll factorize by inspection. And then by inspection, I see that if x is equals to 1, all of these things will give me 0 by inspection. So if I said 0 is equals to, and I substitute 1 here, I'll find that all these things is equals to 0. So that means x minus 1 is a factor by inspection. Is a factor by inspection. And then after that, personally, I use the synthetic division method. So I'll draw my things here. So here I have 1. This one is the one here. And then I have this one from here. And then I have minus 5 there. And then I have 3, this 3 here. So since I know that 1 is one of the factors, I write it here, and then the first one you always put a 0, and then you add or subtract this way. So 1 plus 0 will give you what? Will give you 1. And then you come here, 1 times 1 is 1, 1 plus 1 is 2, 1 times 2 is 2, 5 minus 5 plus 2 is what? Is minus 3. And then 1 times minus 3 is minus 3, and then the last one, as I said in the previous videos, you always have to get 0. So what does this mean? It means that this expression can also be written as 0 is equals to the factor you found by inspection, and then this portion here. So this one will represent your x squared, this one will represent your x, and then this one will represent your constant. So you're going to have x squared plus 2x minus 3. So that's what you'll have there. And then from there on, you can see that you can easily factorize the other side now. So this side can be written as x squared plus 2x minus 3. When you factor it out, you'll have x plus 3 into x minus 1. Therefore, the x-intercepts of your function will be x is equals to 1, which is this one we found by inspection, and x can also be equals to negative 3, and x can also be equals to 1 again, because you have 2 1s. And then it means that the intercepts will be 1 and 0, and the other one will be minus 3 and 0. And then after we found our intercept, I wrote them here. So now we are finding the turning point. And then remember, how do you find the turning point? You find the first derivative, you equate it to 0, and then you factorize. So if I were to derive this thing into the first derivative using the rules of differentiation, it means that my f of x will be 3 times here, it will give me 3x squared. This one will give me 2x. This one will give me minus 5. So I have to equate this thing to 0. So it means that I'll have something like this on this side. I'll have 0 is equals to 3x squared plus 2x minus 5. And I have to factorize this thing. But by inspection, you can tell that the factors of these things are not whole numbers. So there will be a decimal number, something, comma something. So if is that case, I suggest that for you to find these factors, you can use the quadratic formula. And then if you use that quadratic formula, you'll find out that the x value you'll get here is actually minus 5 over 3. And then remember, to get the y value, I have to substitute the x into what? The original f of x, not the first derivative, the original f of x. And then if I do that, you'll find that your y will give you 256 all over 27. So this is your turning point. So one of them, it will be this two, it will be it will be minus 5 over 3 into 256 over 27. This is 256 over 27. And then you'll also find out that the other turning point you'll find is actually what? 1 into x. So this is also what? Your turning point. So what do I mean? When you're finding the intercepts, right? And then you actually find out that x is equals to the same value twice. It simply means that one of those is actually the intercept and the turning point. So the first turning point you'll find is this one, which is minus 5 over 3. Minus 5 over 3. Let me quickly grab this thing here, which is actually minus 5 over 3. Yes, minus 5 over 3. And then the other one is this one. So these are your two what? Turning points. So now let's get to sketching the other graph. So the intercepts you found here, it's what? It's 1. So here to be my 1 and 0. And then remember your y-intercept you found, it was what? 3. So I can say maybe this point is 3, 0 and 3. And then my turning points, it's 5 minus 5 over 3, which is can be somewhere here. So here it can be my turning point, which is minus 5 over 3 and 256 over 27. And then my other intercept of x is what? Is minus 3. So I can say here it's point minus 3 and 0. And then from then on, I sketch my graph. Remember that one of this is also what? The turning point. So one point of x is both our turning point and our intercept, which is what? This point here. But then remember here that this is our original what? F of x. So our a here is greater than 0. So the graph have to increase on the end by going up. So since this one is both an intercept and a turning point, it can go up that way. And then here is what? It's our y-intercept. So the y-intercept here at 3. And then we can go all up the way here to 10 here at this turning point. And then we have to come down into our point, which is x is equals to minus 3. So this is how this particular curve would have looked like. Here will be a turning point, and then here you be intercept. Intercept is minus 3 and 0, and 1 and 0. But 1 and 0 is this intercept and the turning point at the same time. The other turning point is minus 5 over 3 and 256 over 2x. So that's how you will sketch this function. Let's do another example where the graph is actually sketched for us and we have to find the values. Here's another question. We are given this cubic function and then it's sketched for us everything. What we have to do is that we have to find f of x, meaning that the equation of this graph, and also have to find point A. So how do you do that? Firstly, I will say list the things which are given to you on the sketch. You know that when you're looking for y intercepts, you let x be equals to 0, right? So it means that if minus 20 is the y-intercept, it means that y is equals to minus 20, right? But then this one is what is given to you. And then let's look at our x-intercepts. For x-intercept, you always let y be equals to 0, right? But then if you look closely at this graph, you'll see that one x-intercept is an intercept and a turning point at the same time. So what does that mean? It means that when you are looking for your intercepts, you always do this, alright? It means that there's a point where you have a situation when you were to factorize, if you knew the equation, where you'll have x minus 2 into x minus 2. Why? Because that point is used 2 times on the graph, is both the intercept and the x-coordinate of the turning point. 1, 2. So it used 2 times there, so it has to have 2 of the very same factors. And then the other one, the other x-intercept is given to you is what? Is 5. So it means that you had something like 1 minus 5. So that x will be equals to 5 and x equals to 2. And it's true. Why? We are told here that the x-intercept is 2 and 5. So if you were to multiply this thing throughout, you'll find that you get x to the 3 minus 5 x squared plus 4 x minus 20 minus 4 x squared plus 20x. And then if you were to simplify this out, you'll get x to the 3 minus 9x squared plus 24x minus 20. Therefore, it means that the f of x, which is the equation of this graph, is actually what? It's actually x to the 3 minus 9x squared plus 24x minus 20. And if you were to double check it to see if you're correct or not. Remember, if you let x be equals to 0 here, you'll be left with what? With minus 20. So minus 20 is your what? Your y-intercept. It's true. Here it is here. It's given here. And then if one point is both the x coordinate of the intercept, the x coordinate of the turning point and also the intercept, it means that when you're factorizing, you had two of that same factor, which is represented here, 1, 1, and then this x minus 5 is given. So here is how you'll find the equation. So the equation of this graph is this. And then the second question, they said find A. So let's find A. For A, right, remember that A is what? Is the turning point. When we find the turning point, what do? We find the first derivative, we equate it to 0. So if I were to find the first derivative of this, I'll have something like this. I'll have 3x squared minus 18x plus 24, right? So what do? I equate this to 0. I'm following this equation. So you'll have 3x squared minus 18x plus 24. That's what you have there, right? And then if you're to factorize these things, you'll actually find, if you're to simplify it first, you can divide everything here by 3, and then you'll have x squared minus 6x plus 8. And then if you were to factor this out, you'll have x minus 4 into x minus 2. So your x is what? It's 4, and it can also be what? 2. And it's true. Why? Because 2 is the x coordinate of a what? A turning point. So it's also proving that this equation we found here is correct. So the other x coordinate of the other turning point is 4. And even here you can see that, of course, this point is after 2 and 4 is after 2. So you take this x is equals to 4 because it's the x coordinate of A, and then you substitute it into not the first derivative but the original f of x. And then if you substitute that into the original f of x, you'll have, this is the original f of x, remember? Minus 9x squared plus 24. Yeah, sorry. You'll really understand. So this is the original f of x, so it's going to be f of x into 4, which will be 4 to the 3 minus 9 into 4 squared plus 24 into 4 minus 20. You'll find out that the y there is actually minus 4. So A is what? A is actually 4 and minus 4. So you've answered the question. So yeah guys, this is where I'll leave it today. So once again, if you appreciate the content, please remember to comment, like, subscribe and share. Thank you.